Alright, example 3. Find the surface area generated by rotating f of x equals e to the x from 0 to 1 inclusively about the x-axis. And you can see we'll have to do a u substitution here. So if I rotate this around the x-axis, flip it over the x-axis, get some circles in there, identify your radius, just like we identified our reference rectangles in the past. So my y is going to be r of x, which is the e to the x. And the derivative of e to the x, this is great. It's just e to the x, so we can plug this into our formula. So we're integrating from 0 to 1. E to the x times the square root of 1 plus e to the x squared dx. So here, I think what we'll do is we'll do a u sub for e to the x, and then we integrate it from e to the x dx. That's going to be the red and my dx. Here we'll change this out to be 1 plus u squared. And while we'll do that, let's change our bounds. So when e to the 0 power, that's a 1, that's my lower bound. And then e to the first power will just be e. So we'll substitute everything in. And then we'll go to our integral sheet, look for the square root of 1 plus u squared. There it is, square root of a squared plus u squared. That equals u over 2 times the square root of a squared plus u squared, plus a squared over 2 times the natural log of u plus the square root of a squared plus u squared. All right, so then let's substitute everything in. Your a's are all going to be the 1. So my u over 2, square root of 1 squared plus u squared plus 1 squared over 2 times natural log of our u plus 1 square root of 1 plus u squared. And I have two terms here. To simplify this, we'll take these 1/2, if you will, factor them to the front, and that will cancel with the 2. So we'll plug in the e. So pi times e times the square root of 1 plus e squared plus the natural log of e plus square root of 1 plus e squared minus, now we put 1 in for all the u's, 1 times the square root of 1 plus 1 squared plus natural log of 1 plus the square root of 1 plus 1 squared. Not much to simplify here, but over here we'll simplify these 1 plus 1's to the square root of 2. And this would be our exact valued answer that, okay, you'll have to type into your calculator, and you'll get 22.94302234 square units, or again, round to wherever WebAssign wants us to round it to. Example 4, find the surface area generated by f of x equals x squared from 1 to 2, inclusively about the y-axis. So we're going to rotate it this way. And now from my axis of rotation to my function, there is my radius, which is just going to be the x coordinate. So r of x is equal to x. F of x will take its derivative, will be 2x. And we're ready to go ahead and integrate this, and we can still integrate it with respect to x. So we'll go from 1 to 2. X times 1 plus 2x squared, so that'll be 4x squared. So here, let's do a u sub for 1 plus 4x squared. So that's the u, take the derivative of that will be 8x dx. So we'll have to divide the 8 over to the du. There's my x with the dx. We'll just have to put 1/8 multiplied to our 2 pi, which will make that pi over 4. And let's change our boundaries. So again, we don't have to substitute this back. So our upper bound and lower bound. Upper bound, put 2 in for x. That's 2 squared is 4 times 4 is 16 plus 1 is 17. Plug in the 1 for x. That's going to be 4 times 1 plus 1 is 5. So 1/4 pi, or pi over 4, integrate from 5 to 17 of the square root of u du. So this becomes u to the 1/2. Now we can integrate by the power rule, which is u to the 3/2. Dividing by 3/2 is 2/3 as a reciprocal being multiplied. So come back here, 2/3 u to the 3/2. We'll again take the 2/3, multiply it to the 1/4. That's going to give us 2/12 or 1/6 or pi over 6. Plug in the 17 for u, so 17 to the 3/2 minus 5 to the 3/2. Very similar to what we saw earlier. This would be 17 times the square root of 17 minus 5 times the square root of 5 square units. Again, enter that into your calculator, 30.8464897. And that wraps up our 1110.